Good day, everyone. Let us discuss the introduction of integral calculus. So we know that we have what we called calculus. So actually, class calculus, we have two kinds of calculus. So in your first semester at USTP, so you've learned about what kind of calculus was that? So it was the differential calculus. Okay, so that was differential calculus. So in differential calculus, we were talking about. Still remember what are those things that we discussed? We talk about slope, right? We talk about slope, tangent of a line, no? Tangent of a line, or a point or a line tangent to a point in a curve. All right. So we talk about rules in differentiations. It's more about mechanical. No? The process here is mechanical. It means that if you know the process, you know what to do, then you will be able to solve problems. Okay, so it's more about from outside, going inside. So from a big thing going to a small thing. Okay, so from a big thing we are going to make a small thing. That's why we have what we call differentials. Now in other calculus, so we will be discussing for this semester we'll be discussing the other calculus. We called it integral calculus. This is integral calculus. So here we'll be dealing something about finding areas, between curves, volumes. So there are very complex problems that sometimes you can say, oh, how difficult it is. I think there's no way that I can solve this problem. Because it's true, no? In physics, in mechanics, there are problems that it's very difficult to solve, class, but still you can solve using software. But the formulas that is used in the software is the basic formulas that we will be learning from this calculus. So it's something about, for example, if you're given a function, if you can still remember in our calculus, say the function given here is x squared, and if you are going to solve for the derivative of this function, so we have the symbol f prime of x, which is equal to 2x, right? So the process from this function to another function is what we call differentiation. Okay, so this is what we call differentiation. So the process involved here is differentiation. Now to get back to this function from this 2x to x squared, so the process here is what we call integration, or we have what we call the integral. All right, so this is something from the small thing, a lot of small thing and then to get the big thing. It's a reverse process of this one. Okay, so this reverse process is what we call anti-differentiation. Or we call it integration. Okay, so any question? Like for example, so if you're given, say, integral of, by the way class, this symbol is a symbol used for integration, so it's look like an S. So using the concept that we have here small things, and you add it up, then you will get this big thing. So it's something about it's an S, no, an S like symbol, no, to take the sum, no, the sum of small things to get the big thing. So for example, if you're given, say, integral of 2x dx, so the dx here, class, is just the same as the dx that we used to discuss when we were in differential calculus. So dy over dx, or derivative of y with respect to x. So this dx here is the same dx that is here in this integral function. Okay, so if you are given this integral of 2x dx, so as mentioned, no, that the process of getting back here, so is what we call integration from this function, then go back to this function. So we have x squared plus, so we have here c. So this is the what we call the constant of integration. I will give you details on this later on. Okay, so from here, this is the middle of this integral sign and also the dx. So this is the function that we are going to process such that it will get back or go back to this one. Okay, so for example, if you are, or the reverse manner is that if you have this, and then you differentiate this one, then you'll go back to this, which is 2x. Okay, so dy over dx, take the derivative of this one, this function x squared. So we have, so our function y equal to x squared, and then when you take the derivative of y with respect to x, so we have 2x, right? Alright, so we have a differential of y of the function, that is 2x times dx. So you just cross multiply that one, so you have that one. Then d, the d is the differential. Now when you take the opposite process, so you have to, because we have what we call anti-differentiation. So anti means you have to take the derivative of, or sorry, the integral of dy equal to the integral of whatever you do in the left side, do it on the right side as well. So something like this. So we know that this symbol, the integral symbol, is just the anti, meaning the opposite process of dy. Alright? So the opposite process of dy. So it means that y, so it just like it cancels out this, because this one is just equal to 1 over the anti. So 1 over, so it's just like 1 over something, and you have this one here. Okay, so for this one, so what will happen, so it's just like if you have y here, so what remains is this. Okay, so For example, if you have, say, x squared, if you have x squared plus 10, if you have x squared plus 10 and then you take the derivative of this, meaning taking the derivative of this, so you have prime. Prime means derivative of this one, then applying the rules, so you'll have 2x, right? Okay, so it means that you have something here. Your c here is equal to 10. When you take the derivative of this, then it will get you back to this 2x. Or if you have, say, x squared plus 5 or 57,000, okay, then when you take the derivative of this, so what you will get, so that is still 2x, because derivative of x squared is 2x, derivative of this constant 57,000, that is 0, so you will have 2x. Okay, so that's it. This is our introduction for this course, Integral Calculus. So I hope you get the basic concept of this, and we will discuss more in details in our next video. Thank you very much. See you again in our next video. Bye.